Hello and welcome to a new Redbex how-to video. Today we are going to talk about map views. A map view is a feature of Redbex which allows a map-like representation of features and observations. It uses the stored spatial data of features and observations to visualize feature and observation data on an abstraction of the Earth's surface. Let's just get hand-on and have a look to our interface to show you how to create such a map in Redbex. We make use of the presentation ribbon, and there we find the button Map View, and if we press the button Map View, we are getting a user interface to create a new map view definition. If you look on this new window, you will see it looks almost like the window we had to create a chart in the last video, so the structure is almost the same. On the left side we find the space where we make the connection to the data of the feature and the observations. So we have, like we had pins, now we have here layers, and on this area we're going to make the bindings later on. On the right side we have the area where we can see all the settings which are available. Again, we have three different levels of settings. At first we have the settings for the whole map itself, like we see right now, and then later on we will see we have settings for the layers, and we will also have settings for the binding themselves. On the top we again have some tool buttons here. We have the create layer button, which allows us to start the definition right now. We have again the possibility to save the definition of the map as a template, and we can recall it later on. We can export it to a PDF document or to an image, to a raster image. We can make some drawings on our map on our own. We can also make some selections, some measurements, and we can also annotate our map. This is very useful if we save our map as a template, because these annotations will be kept with the template. So whenever another user, for example, opens the template which we are providing right now, these annotations will also then be displayed. And then we have the possibility to switch the layers which we will creating. A layer is one piece of information which will be shown within the map, so the layers are put one on the other, and so it's important to start with the layer, with that layer that has the most area information, because the other layers will be put on this layer. And so if you put, for example, a map at last, then you will not see anything, because the map of course will cover everything which will be beyond the layer. So we start from the bottom to the top, and let's start, for example, for a new layer which could be an OpenStreetMap layer. We have also Bing Map and Google Map layers, but for now let's just create an OpenStreetMap layer, which is quite easy. You will see the layer OpenStreetMap layer does not have any settings here, it's not necessary, and of course, as the OpenStreetMap layer does not show any feature or observation data, there is also no binding necessary for that layer. And immediately after we created this layer, we can press our create map button, and we will see after a few seconds we will be presented an OpenStreetMap within our map definitions, and we can already make use of the OpenStreetMap within our map configuration. Well, of course we would like to see some data of features and observations. Therefore I provided a set of features which has some useful information for this kind. I have here some water levels and some numerical features which have locations already, so we can use them for our layers. For the next layer I would like to show you again a very simple layer, which is the observation location layer, feature location layer, this one here. So this will only show us the position of features which we select to be displayed in our map, and the selection of features is very simple, like we know it from the charts. We just make a binding, we just draw the features we would like to be displayed in the binding area for our new layer here. And now we can see our new layer, the feature location layer, has some settings. When I click this layer, I see on the right side there are some settings which can be made. The first one is very useful. It gives me the possibility to define the zoom according to the data which are resulting by the bindings I just did. So right now all these features will define the area which should be zoomed after creation of this map. So we'll just check it out. I recreate my map definition, and now I see I have here and here you see the features which I have just drawn here, and automatically, because I checked this option already, the zoom area is defined by the binding box of these features here. I could for later on hide the content of that layer, so it will be displayed, and also the zoom extent will be defined according to the content of the layer, but the content itself will not be displayed if I check this option. If I have very much features in that layer, this could be done, could be possible if I do not only make a binding for one feature, but I can also bind, of course, a whole view here to that area, and so I never know how many features actually will be in that view. So if I do not want to wait too long, or if I think it's not useful to have too much features, I can limit the features being displayed on that layer by this setting here. If I use container feature, I can also ask to expand the container features and also use the contained features as a content for that layer here. And if there are different LSO definitions in my features, so not only a point, it could also be a shape, then the question is what should be displayed on the map for this feature. If it has a shape as a LSO, then I could define the midpoint should be displayed as the location for that feature, or I would like the shape itself to be displayed on my map. I decide in this point to display the midpoint whenever a shape is defined as a LSO for a feature. The label of the feature in my map now is the feature name. Of course, I can also change this. I could also have, for example, the feature type and the feature name, or I can use the text template field here to create my own label for my features. But I'm fine with the feature name like it is right now. I can also show the elevation of the features with the name, and also the status can be defined in this setting. And then the appearance of the label of the feature can be changed. The label size can be changed, the color, of course. I can, if there is a line, I can change the line style, the thickness, etc. So you just can walk through the settings and find out yourself what could be done here. I would like to point out one setting which is very interesting. I can define here that a specific symbol should be used on the position of the feature, but I can also choose I would like a symbol I would like not a symbol to be displayed on the position of the feature, but the feature type icon itself should be displayed. And if I just recreate the map, then you will see the effect on this setting. You see here the same icon which is used everywhere in Redbex for this feature type here is also used on the map. So immediately you can see which type of feature is displayed in the map at this position. And if it's too small, you can change the size for this feature type and take a different size for the icon, and now you can see better which type of feature is displayed at this position. And also you have the possibility to change a user-defined bitmap. Then you just choose here a setting bitmap and upload icon which you created on your own on your machine, and you just can create a map using your own image as an icon. I will be fine with my feature type icon here, and I will remain this setting. So as we did some settings already, I would suggest to save these settings in the template, because then you can use it later on. Again, we have this two-step saving template here. The first is the template itself, so the different layers and the settings for the layers. I'll give it a name. I didn't choose a data domain. I have to drag and drop the data domain. It didn't focus to the domain. And in the second step, I can also save the bindings and the settings for the bindings already also, which is very useful. So I do this also, and then you will find here, if you just checked the visibility of map template, which I did here, then you can see in the data domain you will have the node map templates, and there you should see some templates already if there are some, and you should also have the one you just saved, which is my demonstration map in this case. So as we see now our features here, I would like to use a different map, because this map is on an OpenStreetMap, but you could have also some specific map for your project, and this could be as an WMS server. So I would like to add a WMS layer, and I will put this on the top, and let's just delete the OpenStreetMap layer because we don't use it anymore. The WMS layer gives you the possibility to display content of a WMS server, and there have of course some settings to be made, and you see here these WMS settings can be recalled by this U configuration button. If you press this little button here, you will provide a new window where you can just add the content, the settings for this WMS. And I have provided here a URL which gives me the content for a specific region I would like to have right now, and I can query the capabilities of this server, and now it should be possible to choose the coordinate system. I will use this one, and an exception format should be selected. There is only one, so I'm going to take this one. I'm going to take PNG as format, and I don't make use of background color or extra parameters. And then I have to add a layer which I would like to have. I take just the first one, and I don't think there are special styles, so I'm fine with this settings. So I did the settings right now. Now let's have a look what change this setting made. Now I see again the position of my features I was using in the feature location layer beyond, and in the background I see the map which is delivered from my WM server right now. So as we have the locations now, I will show you that it's possible to open the feature right out of the map. If you just right click at the feature, you have the possibility to open a context menu, and this gives you the possibility to open the feature. You can also add this feature to your current selection in the feature browser to, for example, save it later on or use it for another presentation. You can also open the associated data for this feature, and you also can see the alarms on this feature by just clicking show alarms for this feature, and then the pending alarms window will be opened using a filter for that feature which you just opened. Of course, it's not very useful if you have to click all the features being displayed in the map and check out if there is an alarm. So there should be a better possibility, and it is actually, you have the possibility to add a layer which is called, let me just have a look, observation alarm on feature. So I just create this layer. This again is now a new layer, and again I have to make the bindings, which means I have to define which features should be contained in that layer. And I take again the same features I was also using for the feature location layer. And so now this layer will show me which feature actually has an alarm using a specific sign at the position of this feature. And I have here again some settings. I can again use the define zoom extent. I can hide the content. I can limit the features. I can expand also the container features. I can use only alarms which I have obligations on, which means the user I'm using right now has obligations on, and I can limit the observation alarm by entering dates here. But I will not change any of these settings here. Just have a look what happens if I recreate our map. And now I see there's one of these 5 features having an alarm. You see here this feature has got a little symbol here, this triangle with an exclamation mark, and I can now make use of the context menu and open the alarms, and then I see, okay, actually this feature here has one alarm, and I just can see if there is some action to do, and I can acknowledge it or open the feature itself to see the observations which causes the alarm, etc. So I can work on that alarm based on the presentation on the map here. What else could be done? Let's hide. No, I'll just leave it as it is. For example, you could make an isoline using the location of the feature itself. If I just open the feature to make clear what I'm talking about, to show you every feature here in Redbex has now, every feature I'm using now for this presentation has spatial data on feature. So you can see here this feature has now the support of spatial data, and the spatial data is not only easting and northing, but also an elevation is available for every feature I'm using here. So now it is possible to use this elevation value here, which I have on every feature, to make an isoline layer. I just use again these features I have here, and again I have some settings for this isoline layer here. Again, the settings we had already, define zoom extent, hide content, etc. And then I have the possibility to use different algorithms. I can use shading for the isoline, which I will do right now. There is a different calculation base for the isolines. I can define how many decimal places should be used for the calculation, and I can use different colors for the different areas of the isoline itself. And now let's recalculate our map, and then we will see in a few seconds the result of our isoline layer based on the elevation of the feature. Now in our case, the elevation of the feature, I used here too many decimals here. This is not very nice, but however, as we do not want to have, usually we do not want an isoline based on the elevation of the feature, because this elevation does not change. Much more interesting is the isoline based on a value of an observation of the feature. I will make a different isoline, which is called observation property isoline. No, I didn't show you first. I now hide the content of this isoline layer here because I don't want to see it anymore, and I use a different observation property isoline layer. Again, I use the same features here, and in the setting of this observation property isoline layer, I have to make some settings now because this feature has to know which feature type should be used. I tell the system it should be the groundwater level feature type, and then there could be that more than one property would be available for calculating isolines, so I have to specify which property should be used. In our case, there is only one property which is a numeric value, so it's useful for calculation, but anyway I have to select this property, and now I can drag and drop my features to the binding area. Anything else I leave as it is. Maybe we should again shade our isolines, and now if we recalculate our map, we will see there will be some difference, because now the isolines are based on the observation values of the property water level. And now we see here we have isolines based on the water level of our features. We also have a different possibility to display the values of observations of the properties of observations. I just hide this content also because now I'm going to make a new layer which is called observation property as a point. This layer gives me the possibility to display a point on the position where my feature is located, and the size of the point is in accordance to the value of the property I'm defining in the settings. So let me show you. I'm opening the settings for this layer here. Again, I have to tell the system which feature type I would like to work on. Now I'm going to take a different feature. I would like to take the numeric I didn't find it. Generic numeric. We have now the first one is the spatial support on feature. I would like that one now, and there is one property which is just simple called value. This feature type just holds one property of numeric type. And now I'm going to take these 5 features here as a binding. Just let us open one feature to have an idea of what values are stored to these observations here. Here we see we have values between 4 and 500. Just let us open another feature to get an idea of what values we are talking about. And here is 11 to 15. So now I'm going to set the settings for my new layer. Again, define zoom extent, etc. We had this already. The interesting settings here are these two, which is the minimum expected value and the maximum expected value. So this defines which value is the maximum and should be shown as the maximum size of the point which will be displayed on the position of our features here. And in our case, the minimum should be 0 because there is no smaller value as 0, and the maximum I define should be 100. So now let's see what happens if I just execute this setting here. We should see there are some points here. This is the screen circles, and every circle here represent actually the position of one of the generic numeric features we are used here in our binding, and the size of the circle is gives us an idea of the value of the size of the value of the property which we are selecting in this feature. So this is another possibility to display the size of values of properties of features observations. Maybe this is more useful than isolines. For sure it is more useful if the features you're regarding here are in one line. Then it's not very useful to display isolines in this case. Then it's of course more useful to use this presentation where just circles are used and symbolize the size of the value in your observation of that features. Now, as there is no name, I should just make another layer, which is the feature location. And in this feature location I again use the same features which I used in the layer before, and now I define I would like the feature name to be displayed on the position of the features. And now these circles here, these green circles, should also be given a name. And here we see values 1 has the smallest value in the observation, and I would say values 2 has the largest values in the observation property. I have here another feature provided, which is again of the same type, namely generic numeric, but this one is of type spatial support on observation. So if I just open this feature, you will see the feature itself does not have any spatial information, but if we open the observations, we will see every observation which is stored here has not only a value but also has a spatial data here. Now let's use a new layer to display the track of these observations in our map. This can be done by observation track. This is the layer we are using right now, and in the observation track layer I just make a binding for this observation which has support on spatial data for the observation, and I will just keep the settings as they are, just execute the map, and then let's redefine some settings if it seems useful to us. And now we see here there is a track which shows us the different points, the different steps of the observations. Now this label here for each step of our observation track seems to be really large, and I will make it more smaller. For example, I could define I would only have the day in a numeric presentation and the month, and anything else I tell is not interesting to me. Let's execute it again, and then we will see it looks a little more easy to read. We have here the steps of our observation, so we start on 18th of November, and here every day we have a different location according to the different observations in our feature tracker 4711. So let me show you one more layer which is also possible in Redbex. You see there's quite a big list of different types of layers, and of course they are growing because new ideas are coming and getting to the team, and so new type of layers are being developed. As you see, every layer follows the same structure. You just have bindings for some types of layer. For the most types of layers you will have bindings, so because the most layers will just display information of the observation of the feature or feature data itself, so you have to have a binding for features. And then on the right side you can make settings for the layer and also for the binded feature itself. So the structure is very much the same for everything, and I just invite you to find it out how it works. I will just show you one more layer which is a little bit an exception of layers because it does not have binding again. We had already some layers without binding. This is map layers on the top. They just provide a map, so they don't need any features. But we also have different layers which don't have bindings, and here I will show you the axis layer as an example for this. The axis layer just shows you the geometry of a stored axis, and as the axis is not a feature, so this axis layer does not need any binding also. So we just have a look to the settings of this axis layer. Here you find again, you can check the zoom extent, and also you can hide the content here, and then you already can see we have to define an axis, of course, and the axis are stored in the data domain. So I just open the node in my data domain. I defined here in the visibility of the content that I would like to see the axis also, so they are checked and therefore I can see them. And then I will just use, for example, the simple axis here, and now I can define up to 10 different axis reference systems to be displayed, and I will just use both of the defined reference systems here, drive north and drive south. I can define the name of the label of the axis on the map. There's the possibility to show no label or the axis name. I will just keep the axis name. I can display the offset, and I can also show the axis reference systems name here in my map. I will use here some coloring because we already have some type of line here in the map, and to not get confused, I will change the color here. For example, let's make, I don't know, that color, and also for the foreground of the drawing, let's use that color. And I would like the line to be displayed in dashed style, and it should not be thin but medium. So now let's just check it out, execute our layer definition, and then we will see, okay, our axis seems to be out of scope, so it is not situated where everything else is situated, but I just can zoom in, and then we should see here we have our simple axis. Here it comes up. So now actually we are in an area where our WMS server does not provide map content, but if we zoom in, we just see here the axis as it is defined. Just let me try the different axis. Maybe this one has a location where we have, there is only one drive, so this is too much. Let's execute it again. Also drive north seems to be out of the area where we get map information. Here you see this is also a small axis, my new axis. We have the label here, we have the line here for the axis, and we have the drive north here displayed in our map view definition. So to end, at the end I would just again save this definition so we can make use of this definition later on and recall the map whenever we need it. And again, I would recommend to open also the documentation. You will find there some more useful informations also concerning new layer types, how they work and how they can be defined, and which settings are available in the definition of Redbex. Let's just remove this layer because it's not in the scope. Of course, you can also change the order of the layers. You just drag and drop the different layers as you would like them and define them. And then we execute again, and now we can see the result of our layers. Just try it out with your own features. Just try it out. Make your settings, make your layer definition, and find out how this works. You will see it might look a little bit complicated, but you will see as you work on this, it is quite easy to get a nice result. And you will quickly find out how the map view work in Redbex.